Hello, and welcome to today's Mr. Boskin Illustrative Math tutorial. Today we are going over the practice problems for Unit 7, Lesson 10. Okay, the first problem that we have here is find three different ways to write the number 437,000 using powers of 10. Now, our goal with this is to use scientific notation. There are several different ways we could do this. The easiest one would just be 437. Let me try and write the number actually correctly. 437 times 10 to a power. What does the power need to be? Well, there are 3 zeros following that 437, so it has to be 10 to the power of 3. If we want to do it with correct scientific notation, we could do it as 4.37 times 10 to a power. Well, what power are we going to need? How many spots did we move the decimal point? 1, 2, 3, 4, 5. This says find 3 different ways. There's 2. I'll leave finding one more up to you. For the following pair of numbers, select the number which is greater. 17 times 10 to the power of 8 or 4 times 10 to the power of 8. Well, anytime we are just trying to compare numbers, if the exponent of the scientific notation is the same, we can just compare what those numbers are. Which is greater, 4 or 17? 17 is greater. How many times greater? Fractions are your friend. 17 fourths. For the following pair of numbers, select the number that is greater. We again have the same exponent for the scientific notation. Which one is greater, 2 or 7.839? 7.839 is greater. About how many times greater? Fractions are your friend. 7.839 over 2. This one I would not like you to leave it like this, but actually take the time to calculate it. Okay, for the following pair of numbers, select the number that is greater. Uh-oh, now we have numbers that are not to the same power for the scientific notation. However, with this number here being to the power times 10 to the power of 7, and this one being times 10 to the power of 8, if we want them to both be 10 to the power of 8, we can just move the decimal point on this one spot. And this would be 4.2 times 10 to the power of 8. Now which number is greater? 8.5 is definitely greater than 4.2. About how many times greater? 85 over 42, or 8.5 over 4.2. What number is represented by point A? Well, because this is times 10 to the power of 12. There are spots in here. It's divided into 10 pieces, which means each one of these will be 1 times 10 to the power of 11, 2 times 10 to the power of 11, 3, 4, 5, 6, 7 times 10 to the power of 11, and 8 times 10 to the power of 11. Which means here we have 7 times 10 to the power of 11, so 7.1, 7.2, 7.3, 7.4 times 10 to the power of 11. Here's a scatter plot that shows the number of points and assists by a set of hockey players. Select all the following that describe the association of the scatter plot. Now, for the people in my math class right now, this is review of the unit that we skipped. Okay, select all of the following that describe this. That would be a linear association and a positive association. Quick explanation of that. If the data can be approximated by a line, it is linear, and the slope on this line is positive. Linear and positive. Here's a graph of days and the predicted hours of sunlight H on the dth day of the year. So this would be the first day of the year. How many hours of sunlight are there? The longest day in the middle of the year, in the middle of summer. How many hours of daylight are there? Days starting at the first of the year, the days are short, they get longer. Longest day is in the summer, days get shorter again. Is hours of sunlight a function of days of the year? Quick check, vertical line test. Is there anywhere we could draw a vertical line on this graph that would pass through the graph twice? No. So is it a function? Yes, it's a function. How do you know? It passes the vertical line test. Refer to the graph above for the following questions. For what days of the year is the number of hours of sunlight increasing? So, number of hours of sunlight. When is it increasing, meaning when is it going up? It looks like it's going up from day 0 to 150, 60, 70, day 180. So days 0 to 60, yes, it's increasing. 60 to 120, yes, it's increasing. 120 to 180, yes, it's still increasing. For what days of the year is the number of hours of sunlight decreasing? Well, that is the rest of the year. So from 180 to 365, which means, too far. When is the number of hours decreasing? Well, it will be decreasing 180 to 240, 240 to 300, and 300 to 365. Which day of the year has the greatest number of hours of sunlight? Greatest number of hours of sunlight? 180. Which day of the year is the greatest number of hours of sunlight? Day 180. Thank you for tuning in. This has been another Mr. Boskin Helps You With Your Math. For illustrative math, grade 8, unit 7, lesson 10. Thank you.